All right, surface area grades 6 through 8. Not holding back at all. Got the 8th grade formula chart going over absolutely everything that needs to be done for 8th grade. I just think it's much easier just to compact the whole thing and put 6th through 8th together. I mean, you already know how to identify shapes, prisms, cylinders. You understand the area of the base. You understand the perimeter of a base. You understand how to find the actual base of a three-dimensional figure. You understand where the height is of a three-dimensional figure. All these things are the prerequisite skills. And you can see that this stayed the same as it did from volume. The main emphasis is right here now. So you can see in 7th grade it was solve problems involving lateral and total. So, and it's still involved in net. What they want you to do in 8th grade is not necessarily focus on nets, but problem solve with the formulas to find lateral and total surface area. And then we're going to go over some of that. The only thing that really changed is I moved the red area up to surface area instead of having it highlighted in volume. And the other thing that was added was the perimeter of the base. So there are instances whenever you're finding surface area that you will be finding the area of the base, and then you will also be finding the perimeter of that base. It's important to notate the difference, and let's just go ahead and area is the inside, and that's usually done with multiplication. All those formulas are right here. And then perimeter is going to be around the outside. As you're moving around the outside of a shape, the only one that would take an exception with would be a circle, and that would be the circumference. But you can see that that's already taken care of for you in the formula right here, 2 pi r. So that is the same thing as the circumference of a circle. So you're finding the circumference of a circle, then multiplying it by the height, and that'll give you the lateral. And then everything after will give you the area of the two bases, which is why it's 2 pi r squared. Area of a circle. And there are two of them on top and one on bottom, one on top. Okay. So just know that the h also is the thing that separates the two bases. So, if you had a triangular prism, it's the distance from triangle to triangle would be the height of the prism. That's going to get a little more confusing when and if you get into finding surface area of pyramids, because there's going to be another thing called lateral height. That's going to be the distance from the bottom of a triangle to the top of that triangle instead of from the center of the pyramid to the top. So very similar format. These are the two areas we're going to be looking at. These are the two areas I highlighted on the star chart. I just wanted to make sure that we're not skipping any pieces. This would be a triangular prism. The reason it is a triangular prism is because of the two triangle bases that are parallel to each other. These are the only two sides that are parallel on the entire shape. That would make it triangular. The reason it is a prism is because it is connected by three rectangles. Every side of that triangle is connected by a rectangle. They could be all the same size depending on the base. If this is an equilateral triangle, then all the sides of the rectangle are going to be the same. You have three congruent rectangles. And the only reason I'm pointing this out again is because whenever we're going to look at the area, it's going to be of a triangle, and we're still talking about a prism. These are going to tie directly into one another because we're going to have to find the area of the base, and we're going to have to find the perimeter of the base. Knowing what shape we're finding the area of and what shape we're finding the perimeter of is extremely useful because whenever we add the sides up, we know that we should be adding 3, not 4. If it were a pentagon, we'd know we'd be adding 5. These are things and thought processes that you should go through whenever you're solving problems like this, which is why the emphasis is still on keeping organized work. So I'm going to go over to the next slide. It's going to have numbers displayed. They're going to be the same exact numbers as they were for volume, but I just want to make sure that assumptions that we're going to make are made mathematically, and that the format of the work that we're doing is going to be consistent with that of what we did with volume. So whenever I go over to the next slide, go ahead and hit pause, solve that problem the best of your ability, and then let's compare. By the time we get to the end of this, our work should look almost identical, other than the style of handwriting. All right, go. Okay, so you unpause the video after working out the entire thing. I'm going to go ahead and I'm going to highlight the base. That's my first step always. So I know this is a triangular prism. Okay, so I know I got a triangular prism. And moving on, it looks like we can start with always finding total. So it's like, hey, find a lateral surface area. Nope, I'm going to find the total every single time. Because if we find total, we always have lateral. It just helps to solve the problem in its entirety than solving one part of it. In my opinion, if you feel like you are more comfortable in going with lateral, go for it. You know, I just prefer to solve the thing in its entirety. So start with the formula. S equals perimeter of the base times the height of the prism plus 2 times the area of the base. What this is going to do is have us break this down one piece at a time. So here's how we're going to do that. Perimeter of the base. So we can see that the base was a triangle. Only one side is labeled. What does that tell you? It tells you that all 3 sides are congruent. So that gives me a perimeter of 10, 20, 30. 10 plus 10 plus 10. I'm substituting numbers in as I'm finding these. What is the distance from one triangle to the other? 40. Plus 2 times the area of the base. And do you remember what we did before? That's right. We did this work over on the side. We're not doing it near anything like that. We're doing it all the way over on the side. Honestly, you could do it on a separate sheet of paper. My math teachers always emphasized having my formal work on one sheet and having a scratch sheet for my work. Never doing it on the same sheet. So I'm going to go capital B, since we're talking about a triangle, I can say is base times height divided by 2. What is the base of the triangle? Base of the triangle is 10. How tall is the triangle? Well, there's the right angle that tells me height every single time of what I'm looking for. So the distance from the bottom to the top following the right angle is 14. B equals 140 divided by 2. One step at a time. 70 square units. Now I can bring this back over to my original problem. This is where it starts to kind of come together. All right, we have 2 times 70. This triangle was 70, and this triangle was 70. When we add those up, we get 140. That means we have the surface area of both ends of this triangular prism. Now we have 30 times 40. 3 times 4 is 12, plus 2 zeros should be 1200. I'm going to use a calculator just to make sure. And I am correct. Okay. So solving one step at a time, 1,200 plus 2 times 70. And yes, you're sitting there looking at this going, why is he doing that? Why doesn't he just solve 2 steps at a time? One step at a time, man. One step. 1,200 plus 140. S equals 1,340 cubic or square units. And the reason we're doing square units is because we found the area of this down here, this one over here, this one up front, and this over here. It looks like John Madden just got crazy on this, but this is the process on one sheet of paper. This is the process that you're going through on another. If you wanted to, you could put this is number 1 and this is number 1's work. Okay? Keep them separated. So back to what we would call a box. It's strange that the association I make with this is Amazon, but whatever. So whenever it comes to a rectangular prism or a cube, you're always able to choose where the base is at. And if you feel like that needs to be on the bottom, then go ahead and choose the bottom. The result is going to be the same. Know that whenever we are approaching any of these problems, when you have the dimensions, you can just find the area of every single shape and then add them together. For example, this has 6 sides, so we'd be adding 6 areas together. Is that painful to do? Yes. Does it get confusing? Absolutely. That's why formulas are so important and easy to deal with. I'm going to go ahead and just stick with what I know, and I'm going to go with orange as my base. And we know the distance between this side and its parallel side is going to be the height of the prism, because we could always just kind of flip this prism to where the orange is on bottom, and then we have like a flat box standing up. And then that would be the height. Blue would be the height, how tall it is from bottom to top. So the orientation of the figure is not necessarily the deal breaker in determining where the height or the base is. Because, I mean, boxes can move. All right. What we're going to be looking at is a rectangle as the base, and we're still talking about a prism. And I'm always going to go for total. And when I hit total, I'll tell you which part is going to be the lateral, and you can always refer back to your formula. It's just going to be the first part. Every first part of a surface area formula is lateral, and then it's always adding the bases on after. So that's where the 2b comes in. That's where the 2 pi r squared comes in. So I'm going to go ahead and flip over to the next one. We're trying to see how much wrapping paper to the exact amount it would take to cover this box. All right. So see how close you can get. Whenever we go to the next slide, pause the video and give it a shot. Remember, clean work on one side and then other work to do the side stuff over on the side or on a separate sheet of paper. All right. Pause. All right. So we already agreed that we're looking at a rectangle, and we already agreed that we're looking at a prism. No, I didn't ask you because I can't talk to you over a video, but I mean, we can play pretend real quick. Hey, did we talk about that? Oh, good, good. Thank you for your response. I appreciate that. Yes, we did. Okay, good talk. So I'm sticking with orange as my base, which means that I have a height of 20, always starting off with just writing the formula. Prism, S equals perimeter of the base times the height of the prism plus 2 times the area of the base. All right, so I've got my orange base, and I know that I have to find the perimeter of it. So how do I find the perimeter of a rectangle? I just add up all the sides. The only thing I can't do that with is a circle. Just keep that in mind. So 18 plus 18 should be 36. Plus 6 plus 6. And on my calculator, I can see that I have 4 numbers added up. 2 of them are the same, and the other 2 are the same, because we have 2 sets of parallel sides, which is what makes a rectangle. So if we have those, and we know it's a rectangle, then we know we have 2 pair of congruent sides, and we add all 4 of them up, we get 48. Distance around the rectangle is 48. Distance from orange to orange is 20. Could you take a different approach on this and choose blue as your base? Yes. That would change the perimeter, and it would also change the height of the prism being 18. Plus 2 times the area of the base. And you know what I'm about to do. Blam! All right, so I know that we're talking about area now, so I'm going to go capital B, which is area of the base. And I'm substituting capital B in for capital A because I just want to make sure that whenever I get to my final answer, it says capital B equals. Because that's the thing I'm solving for right now. See, look, the arrow went from capital B over there. So a rectangle, base times height, easy. So area of the base equals base 18 by 6. And you could do 6 by 18. 18 times 6 and 6 times 18 are the same answer. Just know that whenever you have base and height and you're looking for two dimensions, that those things are interchangeable. The only time that's not interchangeable is whenever you're looking at a three-dimensional figure and you're trying to find the height, which is the distance between the two bases. So we have 18 times 6. Let's take a looky-loo, shall we? Capital B equals 108. That's what you should have gotten for the area of your base. I'm going to plug this back in right over there. So just like the order of operations, we're solving this one step at a time. Right now there are 3 operations. That means I should be writing 3 steps after what I already have written. Since we know that 48 times 20 and 2 times 108 are of equal power, that means we're going to solve from left to right, getting the first multiplication done, then the second multiplication done, and then finally doing addition, following the rules of PEMDAS. Because we solve problems always using the order of operations. So first step, 48 times 20. Should have got 960. Rewrite the problem. Okay. Now we know that we're supposed to do multiplication before we do addition, which is why I said the equal power, so left to right. So we're going to do 2 times 108 now. So 960 plus 216. Being thorough with mathematics is how people have discovered things about the universe. So to think that, as like student, teacher, we're better than people that have discovered things about the entire universe based solely on mathematics. To think that we can skip steps seems, ridiculous. So just don't skip any steps. You don't see Albert Einstein skipping steps. If anything, he made more steps for us. All right, so S equals 1,176 square units. Keep in mind that we have found lateral and total on this last spot right here. Lateral, total. Every time. Every time, every time. It's always going to be there. Always going to be there. I would have all of my students find total surface area and then understand the formula to be able to tell me what the lateral surface area was. I would even be able to get them to tell me if I wanted to cover only the bases and not the sides, what would that be? And they were able to tell me. It would be 216. That would be the bases. This is the sides, which is lateral. And then this is total, the sides plus the bases. So I wanted to go over cylinders again, because circles are the bane of every single middle schooler's existence, and the thing where they look at it and go, it doesn't have sides, how am I supposed to add it up? Well, that's why you have a formula chart, and that's why I keep on emphasizing the formula chart. So we have a cylinder, which is going to be a circle and a cylinder. Those are the two things that go together. You couldn't choose a circle and then pick a prism. It's not connected by rectangles. It's one rectangle wrapped around a circle. So one thing I want to talk about here is also the radius, because that's going to wear you out, and then also the diameter. The same thing I always say, diameter is a longer word, you get the longer line. Radius is the shorter word, you get the shorter line. Anytime you have a diameter and you want to find a radius, cut it in half. It's half the distance. So the only thing you need to know is that when you're dealing with pi 3.14, know that order of operations is going to kick in immediately because you have an exponent, and always be aware that you're going to be dealing with a radius. If you're given a diameter, you must find a radius. I'm going to switch over to the cylinder, and we're going to go through that together. And I really want to talk about the types of variations in problem solving that you could go through whenever you have a cylinder and you're trying to find surface area. Go. Okay, so you should have paused it. Should have worked this out for a little bit. I'm going to go ahead and highlight what we already know. The area of the base is going to be a circle, and we're talking about a cylinder. So obviously the base is going to be a circle because that's inherent with having a cylinder. You can't have a cylinder without a base of a circle, actually two parallel circles. And the height is going to be the distance between those. I like cylinders because they're very straightforward. They don't give you a whole bunch of information, but the thing that you take in exchange is the complexity of the formula. So I'm just gonna keep on emphasizing this. Do your formula work on one paper and do all of your scratch work on another. If you want to use a calculator to solve all these things, at least write down what you're typing in and then go back to your original formula sheet and write the answers in there. Have all of your scratch work. You can see that even I'm writing the stuff out and I'm using a calculator. The only difference is I'm just not solving all of it by hand. So let's start with the surface area formula since that's what we're working with. And we'll talk about practical applications of surface area with a cylinder once we get through with the problem. 2 pi RH plus 2 pi r squared. All right, so 2 pi r, that is the circumference of a circle, the distance around it. So that's our perimeter. That's where pH plus 2 capital B. We could still use the same exact formula, but when it runs into a technicality because you're finding the perimeter of a circle. Perimeter of a circle is called circumference. So let's go ahead and write out numerically what we're going to actually be doing here. Height was 10. The radius, it's a shorter line, so we're good to go there, 6. Okay. Whoa. Here is where the entirety of the organization comes into play, because you have a lot of wonky numbers, you got a lot of multiplication, you got addition, you've got exponents. So whenever going through PEMDAS, actually use the rules of PEMDAS. Do you see parentheses? Yes. Is there anything inside of any of those parentheses we could do right now? No, there's only one item inside of each parentheses. Okay. Do you see exponents? Yes. That's what you're going to do first. So yes, I am going to rewrite this whole entire thing. To only get to the end and simplify 6 squared, which is 6 times 6. Now, we're getting into something where we can actually type it into a calculator and break some rules. So if you wanted to, the most correct way to go about doing this would be to do 2 times 3.14, rewrite the whole entire thing. And then do 6.28 times 10, and then rewrite the entire thing. Then do the other half and then add them up at the end. What I'm going to do is type in 2 times 3.14 times 10. And then I'm going to rewrite that. Now, since we're talking about equal powers of multiplication and multiplication being separated by addition, I'm going to do the multiplication first on both sides and then finally wrap it up with the addition. So S equals 62.8 plus 2 times 3.14 times 36. 226.08. So when we're looking for total surface area, right now we've got lateral. There's lateral right there. Now whenever we add this with 62.8 and 226.08, we get 288.88. So S equals 288.88 square units. Okay, so since we used 3.14 and we didn't use pi, obviously it's going to come as some sort of a approximation. If we use the pi button, it would still be an approximation, but it would be more of an accurate approximation. So the thing I want to talk about here is we've got lateral, and we've got total. The practical application of a cylinder is if you're driving through any farm town and you're looking at a silo, which is basically a cylinder with like a cone on top of it sometimes, you know, then they put like feed in it, and this is full of corn. So this is where volume and surface area come into play, but let's talk about surface area. So typically around the sides is where you'd see paint, and this would be like shiny metal up top or rusted or whatever. So whenever people are doing these things, they want to do things in a cost-effective manner. Whenever they do this and they call for someone to come paint, they hire someone, that person is going to calculate the surface area of the place that needs to be painted. So they'd be finding the lateral surface area of this silo. They'd be like, okay, how wide is it from one side to the other, which would be the diameter. Then they'd find the radius from that, multiply it by the height, and they'd basically just be doing where the blue outline is and finding 62.8, let's say, square feet. For every bucket of paint, there is a label wrapped around it. The same exact thing is done, and on that label, it says the approximate amount of square footage that it will paint to the standard that the company is promising it will cover. So, I mean, if like you want to do like a really light layer over like 5 rooms using 1 can of paint, you could, but it wouldn't look good. So for the utmost quality and the standard that the company is saying, they say, well, you could paint 50 square feet using this bucket of paint. That means that this guy would know that, okay, I gotta go buy 2 buckets of paint, because the thing that is absolutely horrible is getting started on a project like that, running out of paint and going like, I gotta stop right in the middle of it and go get another thing of paint. Why didn't I figure this out beforehand? So math is practical. Math does come into play. Take a look at any soda can, any label. Those labels are measured out to the exact amount that's going to be used, because any wasted space or any wasted materials costs money. So just know that they have a machine that is calculating the exact lateral surface area of every single can, wrapping it and sending it out. The next part is, I noticed on the volume part, I didn't see any pictures on your work. And not to say that that's a knock on you, but I am saying that visuals are a good thing. And whenever you're given a word problem, the first thing that you should be doing is identifying key information and then drawing the picture to the best of your ability. Does it need to look like an art project? No, it just needs to look like something you can reference. So a treasure chest. I'm gonna draw a treasure chest. And you know, like I know that not everybody can draw treasure chests and stuff like that, and that's fine. I'm not saying that you need to be able to draw one or anything like that. But the idea, at least, of seeing a treasure chest, and then you can see the shape, and we can talk about what it's going to be, asking for. Then we can at least have a discussion about what we're looking at. Treasure chest is a composite figure, which means that you have an oddly shaped figure because it's made of more than one shape. If you were to paint the surface area, how many square feet would you paint? All right, so the thing that we're going to focus on is this. So we're not going to paint the top portion, even though we could, and I'm going to get into that in just a second. But I want you to just think about for a moment, how could I find the total surface area of the box on the bottom and then the curvy part on top? What does that look like? Pause the video, think for a moment, look at it. Okay, so whenever we're talking about composite figures, just like if we were looking for the area of something, and it was like this. You're sitting there going like, that's a weird shape. Yeah, it looks like the top view of like like a Capitol building or something. So this is a composite shape because it looks like a rectangle with half a circle. Now, whenever we turn this into a three-dimensional shape, it would look much different, but we would still have the three-dimensional counterparts of the shapes that we identified. So a rectangle, boom, rectangular prism. Half a circle, a semicircle, extended, turns into a cylinder, and that's just half of it. So that's what we're looking at up here on the top of the treasure chest, is a cylinder, its total surface area cut in half. Okay? So whenever we're talking about surface area, this is where the brain comes in and not just math. And the reason why I'm going over this is because I want to show you the variations and the types of things that can come up and the type of thought process that has to go into this. There are no numbers. We're not going to solve this problem. This is just a situation. So I want you to think about how many sides that you'd have to paint of the bottom of this chest. Okay? Pause the video, think about it for a moment. Okay, so you should have thought about it for a second, and it's maybe a trick question, I'm not sure. So whenever we open the chest, is there going to be a side on top that's a completed box that we're going to be painting? No, because then it wouldn't be a chest anymore. It would be like a trick chest, I guess. So we're missing one side from the box. So that means we're finding the lateral surface area, which is going to be the sides. There's going to be 4 of those. Then there's going to be one base on the bottom. That's where 2B will change into 1B. This is why you learn the other methods of finding surface area, total surface area, lateral surface area by using a net whenever you have it all broken out into a 2-dimensional shape, which is also a composite figure. And then also why you're able to identify the pieces and how many you should be adding up together. In this case, it would be 5, not 6, because we want stuff to go into the box. Then, taking a look at the semi-cylinder, which is this, cut in half. Okay? That just means that we found the total surface area of a cylinder and then divided by 2. These are just the types of strategies and thought processes that you should be moving through whenever looking at a word problem and the strategies you should be using. I drew a picture of a chest. I drew a picture of the cylinder cut in half, maybe divided by 2. This is planning a problem. All right, I'm not going to say anything about this. I want you to pause the video. I want you to take your time. I want you to think about this. I want you to just take this apart and see where you can get. And let's see if we have any discrepancies or disagreements. All right, go. Okay, so you should have paused it. It says excluding the door, which means not including. What is the lateral surface area of the storage shed in square feet? So there's 2 key parts here. Excluding. So I'm not including the door. Lateral surface area of the shed. Okay? Square feet. So that just says no door, lateral surface area, which means no bases, and square feet, emphasizing finding area. So if I wanted to determine what kind of shape this is, it would look like I'm dealing with a rectangle, and it's going to be a rectangular prism. I'm going to go with what I've said from the beginning. I'm going to find total surface area, and I'm going to use the pieces that I need. So S equals PH plus 2B. So perimeter of the base. I'm going to stick with something simple, and I'm going to go with the bottom. Makes sense since we're looking at a actual practical shape, you know, and it's a shed. So I mean, if we walked into the shed, we'd look at the floor and say that's the base. So perimeter of the base. This has to be done. So that would mean that I'm adding up 4 sides, which is 30, 8, 30, and 8. 38, 38 should be 72. 76. The distance from that base to its parallel side is 12. That's going to be the height of the prism. So 12 plus 2 times, you know what I'm doing here. Over on the separate side. I'm keeping all my work nice and neat over here. This is the product I want to turn in. Over there is my proof of how I got my product. So capital B is going to be capital B equals base times height. So you're sitting there going, why am I even doing this? Because it's talking about lateral surface area. To be thorough. So 30 times 8 is 240. 240 square feet for the top and the bottom. We know that we don't need that, okay? What we do need is this right here, our lateral surface area. And you're sitting there going, oh, that's actually kind of easy. Oh, but we're not done yet. So 76 times 12. S equals 912 square feet to paint, right? That's it. Wrong. The reason we highlighted excluding at the very beginning is because we don't want to paint that darn door. So this is where composite figures come in of subtracting area. So this was like a 6th grade concept of if you had a yard and it was full of grass and you had a swimming pool in the middle, how much of the lawn in square feet would you have to mow? So that means you'd find the area of the lawn and then subtract the area of the circle, and that would be what you have left. That's where this concept comes in. So what we're looking at is subtracting the area of the door. That's a rectangle again. That's area equals base times height. So I'm going to have a little arrow pointing down here going area equals base times height. 4 times 9, 36 square feet. Okay? That is going to be removed from this. Minus 36. The square footage that we would have to paint to the exact amount would be 876 square feet. Now we have all of the information we could possibly need about this shed, right? We have the area of the door. We have the area of the bases. We have the area of all of the sides. We have the total surface area. We have everything. You could answer any question that follows this based on the information that you have, which is absolutely everything. So the reason I want you to include everything is because I also want you to know what to do with the pieces. These are not just numbers. These are pieces of real things that are happening. So I want you to be able to identify those pieces. Remember, the first part is always going to be lateral. So I put a piece of paper here because I want to emphasize your work goes, your formal work goes here on a scratch sheet of paper. Okay, over here, you're doing B equals base times height divided by 2, and you're doing B equals, 8 times 9, 2, B equals blah, divided by 2, blah, blah. This is all the scratch work. This is your formal work. Organization will pay off, sir. You need to trust me.